This is Charlie Milburn for Hit Exchange Media. I'm joined by Hit Exchange Executive Editor Eric Hibbs via remote broadcast. Recently, Eric had the opportunity to visit IBM, where Dr. David Ferrucci discusses the supercomputer known as Watson. Welcome, Eric.
Thanks, Charlie.
So, set this up for us. What does Dr. Ferrucci talk about?
Dr. Ferrucci is a fellow at IBM and principal investigator of Watson Deep QA technology. In this footage, he's talking about the Watson project and the potential for it to change the way that medicine is practiced.
Sounds intriguing, Eric. Thanks. Here's Dr. Ferrucci.
My name is Dave Ferrucci. I'm actually an IBM fellow at IBM, but I've been leading the Semantic Analysis and Integration Group, which is a group focused on artificial intelligence, but more specifically on natural language processing, trying to get computers to do a better job at understanding human language, what does it mean, what it's about, how to ultimately answer questions by analyzing and digging into the meaning of that content. I was the team leader on the Watson project, so something we call the principal investigator. So I was responsible for the research agenda, for how do we architect the system, what different algorithms do we develop, how do we measure and drive the system to perform as a contestant on Jeopardy. So the biggest investment was in development of the core architecture, what we call the Deep QA architecture, which underlies Watson, and the development of all the algorithms that plug into that architecture. And that was the main technical investment. And the algorithms range from natural language processing algorithms, knowledge representation and reasoning, machine learning algorithms, information retrieval algorithms, so the, computational linguistics, parsing, so many different classes of algorithms were developed to plug into the overall architecture. And that was the main investment on the technical research side. Another investment, which was a significant one, not as much as the algorithm investment, was in the speed and optimization. So how do we scale the system, deploy it on the IBM hardware platform, and get it to run fast enough to compete at Jeopardy? Obviously, IBM didn't invest in building Watson as a way to generate a revenue stream by winning at Jeopardy, right? So this clearly was not the focus. But I think two things were understood fairly early on. One was that huge amounts of information out there captured in natural language content. Documents, news, blogs, textbooks, reference books, encyclopedias, dictionaries, huge wealth of knowledge, journal papers, abstracts, research papers. So just an enormous amount of information out there that could impact decision making, whether it be in healthcare, whether it be in business intelligence, whether it be in finance, whether it be in technical support, when we talk about guidelines and user support manuals, all this kind of stuff. Huge wealth of information, not carefully encoded in perfect database tables with exact, precise queries that are, determined a priori and anticipated. But now we're talking about unanticipated questions, problems people have, and the answers are out there in this, what we call unstructured content. How do you get at it? This is the technology that we knew that if we pursued Jeopardy, we would be tackling, we would be exploring, we would be advancing. Because that's the kind of technology that was really needed to solve the Jeopardy problem. But the expectation was we would do this in a general enough way that we can now take that technology with that vision in mind, that we're going to be able to do a better job analyzing and extracting valuable knowledge from unstructured content, that we're going to take what we did with Jeopardy and apply it to these other domains. And one of the ones that was most exciting and sort of caught our attention was healthcare. Numerous reasons. I mean, one is a very personal reason. I got into AI got excited about it back in high school, and one of the things that drove me was applying it to medicine. I was actually pre-med in college and originally was going to become a medical doctor, but got so excited about technology and the potential for technology, I got involved in expert systems. But one of the challenges with classic expert systems in the area of healthcare was that you'd have to sort of encode every possible rule, every possible relationship, every little nugget of knowledge would have to be carefully encoded in a formal language, in a formal knowledge base. And then every query to that knowledge base would have to be anticipated ahead of time so that it perfectly matched the way you encoded that information for the computer in that knowledge base. This became an enormous bottleneck, what we call the knowledge acquisition bottleneck, because now people would have to work hard to encode this knowledge in a perfect way, and then anybody who queried it would have to anticipate or understand how it was encoded. This was just made it very, very difficult to capture and exploit medical knowledge. But with Watson, we're doing something very differently. We're saying we can get the kind of precision, the kind of answers, the kind of evidence, whether it be support for differential diagnosis, whether it be an assessment of various treatment options, whether if it's qualifying or determining, rationalizing whether or not a test is required. We can do all these kinds of things now by analyzing and reading, if you will, huge volumes of unstructured content. So no one's out there formulating, curating, massaging, and formalizing this knowledge. It's out there the way humans would create it, the way they would create it to communicate with one another. And now this technology, this Watson technology, is reading and understanding it exactly in the form that humans normally create it. Again, to communicate the knowledge with one another, and extracting that, finding answers, finding evidence, weighing and assessing that evidence, helping the decision maker, whether it be the doctor, whether it be the nurse, whether it be the patient, whether it be the insurer. Saying, look, there's a lot of stuff out there. I've gathered all the relevant evidence. I've assessed it and weighed it and said, here's why this treatment might be more appropriate than this other treatment. Here's why this diagnosis starts to look more interesting. Present that to the professional in ways that the information becomes more accessible, more digestible, more consumable than if they had to go out and find all this stuff themselves. With Jeopardy, you see question and answer out. We don't really want that for applications. That's when we talk about decision support, when you talk about informing professionals, helping them get access to the information they need, just delivering an answer is not sufficient. What happened in Jeopardy is you saw that answer panel that showed the top 3 answers, and it showed the confidence associated with those answers. That confidence is coming from a deeper analysis of the unstructured content. It's coming from what we call an evidence profile. So the way to think about Watson is that when that Jeopardy clue went in, think of that as a bunch of facts about some unknown entity, whether it be a treatment, whether it be a disease, whether it be a test. And what it's doing is it's saying, look, this looks like a clue, looks like a question to you, but really it's a case, it's a body of information, because even in Jeopardy we consider not just the clue, but the surrounding clues in that category, the category title, and we extracted from that a bunch of things that are true about the unknown entity, the answer to the question, and then it generated many possibilities, possible answers. For example, possible diagnoses or possible treatments. Then it goes out and it reads all that content it has available to it, potentially the equivalent of millions and millions of books, and starts to extract and organize and assess the evidence that supports, to varying degrees, those different diagnoses or treatments, produces a confidence. What you get in a real application, not in a game, you just get a single answer. You get that whole evidence profile. What the professional gets now is, here are the different things that were considered, here are the different documents and passages that were read, and here's how the computer assessed them. And this is why it comes up with the 85% or the 90%, giving that human professional direct access to the evidence that the computer scored. This is what we call an evidence profile. So Watson's ultimately not about question in and answer out. It's about, here's a body of facts, here's a bunch of information. For example, information about a patient. And what I want to know is, what's the likely disease? What's the unknown entity? Or what's the likely treatment? And what you're getting back now is the evidence profile that supports all those answers. So if you think about it, there's 2 kinds of applications out there. There's text-based applications, sort of web search. So now I can just give it any information you want, right? You just throw it in there, no one analyzes it, no humans, just whatever it is, however you wrote it. But what you're getting is a very broad coverage, meaning you could look at all that data, because it didn't need a lot of human preparation and curation or organization of the databases. It just came as a bunch of text, right? And you put your keywords in, and you get back the documents containing those keywords. So you get broad coverage, but you get very limited precision. The computer didn't work to really understand what you were asking. It didn't work to really understand what the document said. It just said, here's the popular document with those keywords. And now you get hundreds of thousands of them, if not millions of hits. Now what? There's no way you as a human are going to be able to dig into those hundreds of thousands of hits or millions of hits and figure out what's going on. So it's a very limited kind of paradigm. On the other extreme are classic database and knowledge-based systems, and that's what I was referring to before. Now you need to carefully encode every fact into a formal database or knowledge base. You get very limited coverage. You can't cover all the knowledge that's out there. It takes too long, it's too tedious, and when you're done, it's very brittle. What do I mean by brittle? It takes on a particular organization, and if your query doesn't match that organization, even though the answer might be there, you don't know, because you didn't get that perfect match. What Watson does is, in effect, it gives you more access to better access to more information. Why? Because it doesn't require you to go through that narrow bottleneck where you have humans perfectly organizing things into a perfect schema and that brittle structure. It doesn't require that. It gives you the breadth you typically get when you do text-based search, which allows you to take any content, however the humans wrote it, and lets you ask any query however you want to express it, but it gives you higher precision. So there's an enormous amount of information out there. It's already available in electronic form. Do we have the smarts to assess it, analyze it, and present it in a way that it makes it consumable and accessible to the human? And I think that's where Watson comes in, and that's where Watson comes in and makes a difference. Think about the sort of challenges when you commit to saying we're going to take information the way humans express it. We're not going to go through this formal, tedious data curation organization and sort of process, standardization process. Now the computer has to be able to tell that a patient has difficulty swallowing, a patient experiences pain when eating, a patient has dysphagia. They all mean the same thing. How do you know that? Those are very, very different words. So now the computer has to get smart about looking at the words, the nouns, the verbs, the relationships that exist between them, and being able to now access dictionaries and ontologies and thesauri and look at statistics about how words are used in different contexts and come up with some confidence that if one thing says the patient has difficulty swallowing, something else says the patient has dysphagia, something else says the patient is experiencing pain when eating, throat pain when eating, these may all mean exactly the same thing. How do I know that? So that's what Watson technologies are about, how to train the computer to get better at understanding whether two very different expressions might mean the same thing, whether they mean exactly the same thing, whether one subsumes the other, whether one entails or implies the other, even though they're using very different expressions, very different words, very different phrases, without writing them all these equivalence classes down. I can't anticipate, right? So instead I have to make the computer smarter at processing the natural language by using the kinds of resources a non-expert might use as they were training up in that domain. The different kind of partnerships we're developing, one is with universities that help us with the core technologies, certainly with partners or potential customers who would help us understand what are the use cases, what are the pain points, how can this technology apply and help improve quality or reduce costs. Other partners that have unique technologies, for example, like Nuance, that does the work with dictation and speech recognition, which is a part of the challenge, a part of the problem. How do you deploy the technology in such a way that it doesn't burden the user, but it makes the interfacing with the system more natural? So there are many different kinds of technical partnerships we may look for, but that's sort of the landscape, right? So core technology development, core research, technology partnerships where people who have developed certain elements of the solution can tie in together with Watson, and of course with developing relationship with customers that come and help us better understand what the problems are, what the pain points are, how we best fit and apply and deploy the technology in a way that again improves quality or manages or reduces cost.